Another photoelectric effective question, same basic question. If I give you a lambda and a work function, you should be able to determine the outcome, whether electrons are ejected or not. And if they are ejected, you should be able to tell me the maximum kinetic energy of those electrons. Planck gave us an equation to connect the frequency or wavelength of light to how much energy it has. For these particular numbers, h is always the 626 number. Speed of light is always 3 times 10 to the 8. But for this one, I've changed the wavelength. It is now 450 nanometers, which is 4.5 times 10 to the negative 7. Crunching all that out and going to 2 decimal places, I get that the energy of each photon of light is 4.42 times 10 to the negative 19 joules. The work function was given as 2.3 electron volts. Electron volts are a convenient unit of energy if you're doing particle physics and different things than what we've done in class lately. Well, until now. Really, it's just another unit for energy. To convert to joules, we multiply it by the charge on an electron, the 1.6 times 10 to the negative 19 number. Oops, did that upside down. Joules per electron volt. Multiplying that across the work function, when we put it in joules, I get 3.68 times 10 to the negative 19 joules. There is the equation, but I just like to do it this way instead of, I just sort of think it through. Each bullet of light has an energy of the 4.42 number. The work function is 3.68. Therefore, there's enough energy. Electrons will be ejected. And if we go one step further, the kinetic energy they have is the difference between those two numbers. It's like walking into a store with $4.42 and trying to buy something that costs $3.68. The difference is how much change you get back. In this case, roughly 0.74, that's not the best notation, times 10 to the negative 19 joules, or we could call that 7.4 times 10 to the negative 20. It's called the maximum kinetic energy. These bullets of light, these photons hit the metal. Maybe they don't hit it quite cleanly. Maybe a photon kind of hits on a funny angle or hits two particles at once. So it's possible that the photon hits the metal and ejects an electron, but because it's not a clean transfer of energy, the electron has less than that 7.4 number. But in a perfect, we could call it 100% efficient collision, if all the energy of the light is given to the electron to liberate it, after taking off the work function, the most kinetic energy that that electron could have is if it got all the energy, and that's the difference, the 7.4 in this case. So we call it a maximum kinetic energy because it's possible the electron could have less if it wasn't a clean collision, or it could have up to a maximum of that 7.4 number.